Thank you for the introduction. This session will be in Japanese. So this is the overview of the presentation. We do operate multiple businesses, but using quantum computers, we would like to use them for a wide range of businesses. And we do see evolution of quantum computers, but calculation capability will hit a wall. Beyond that, it would be very difficult to extend. In order to ensure sufficient calculation capability, what we want to do is to connect quantum computers to make a large virtual quantum computer. And I think that's a very important initiative. Including that, we would like to introduce what we do in the area of quantum computing. First, I'd like to introduce Mitsubishi Electric. This shows our business areas from home appliances, infrastructure, defense, and space. We have covered a wide range of businesses. So we do have multiple businesses, as I said, and there are lots of data from components and systems. We can use that data in a digital space for us to be able to analyze data, apply that to digital twin or AI for optimization purposes, or offer customer values. So we are actually using that for our services. And then from those services, we acquire more data for inputs. So it's really a cycle-based digital engineering. Analysis and data collection require a high level of security. And in every one of these aspects, I believe quantum technology can be useful. So we've done a lot of initiatives, including electric equipment, building management. So we have multiple equipments and devices, and they used to be separate businesses. The data that we get from these different businesses can be combined together to come up with a common digital platform, which is now called Serendi. So the information here can be integrated for various analysis and optimization, and the result can be fed back to different devices and equipment. And this is where we want to apply quantum technology eventually. So we are currently working with Mitsui and company and Continuum as well. Continuum is a company of quantum computer system. And we have components, supported technology, a quantum connection, and digital platform that I introduced as Serendi. And also Mitsui and company can come up with future application areas. And this is how we can collaborate to promote the quantum technology. So the challenges that we are looking at using quantum computer, what we are going to do. There are various analysis and optimization work that we want to carry out. Logical bits number can or tend to be very high. Now these lines, I think what is important is this the angle. The classic computer is indicated by a black dotted line. Currently, quantum computer is not up to the level of supercomputer, but if you look at the classic computer, it is possible to enhance its calculation capability according to the Moore's law. Then quantum computers are indicated by orange line. And there have been multiple presentations made today. We expect the performance is to get accelerated. Having said that, there are physical constraints such as volume, electricity, integration density. These are some of the classic physical constraints. So these constraints may decelerate the growth rate. And these classic constraints can also limit the growth of quantum computers. So what we want to do is to connect, for example, 8 quantum computers to come up with a large quantum computer. You can connect 256 computers to come up with a large virtual computer so that we can actually make a breakthrough solving these constraints. To make a quantum computer, the virtual computer, have a supremacy or advantage over the classic computing. So Mitsui and Continuum, and altogether 7 companies are joining forces together to connect quantum computers. This connection technology is now being demonstrated, and this is the purpose of the joint effort. In Kawasaki City, specifically EBIC, we are a resident in this building where we are currently constructing the demonstration environment. And these are the 7 companies. Our company, Mitsui and Company, Continuum. In addition to these 3, SoftBank is developing or reviewing development items of quantum network technology. And also, Luqom, the quantum repeater company, is joining. And also University of Keio University as well as National Yokohama University are providing basic research on quantum information transmission and quantum application technology. So 7 organizations are trying to expand the calculation capabilities of quantum computing. So like I said, in order to realize quantum connection, what could be elemental technologies that are required? Including universities, we have joint research to promote the basic research to deal with this question. And quantum error need to be corrected. So quantum error correction technology is also another topic that we're working on. Through these joint research activities, we would like to enhance quantum calculation capabilities so that the quantum computing can be applied to various wide range of applications. That is what we want to achieve. From here onward, I'd like to pass this microphone to Naniwada. Thank you, Mr. Sugimoto. So he talked about the businesses and applications, and we're in charge of applications, so let me talk about the applications. CN Company is studying technical trends as part of DX activities. Quantum technology, we believe, has a great potential. And since 2018, we have placed much focus on this. That's when we started our activities. We would like to achieve commercialization eventually. In 2022, we set up Quantum Innovation Office, and that's where I belong to. It's not that we have quantum technologies. So we need partners that have high quantum technology levels. Quantinuum is one of them. That is why we set up a strategic partnership with Quantinuum in 2022. And as we collaborated, there has been funding opportunities, and we concluded a contract to become a distributor for Quantinuum to selling Quantinuum products and services. In quantum token and other experiments, Quantinuum has the basic patent over this. NEC has provided devices for our demonstration. This was done last year. So using quantum computing, what do we want to achieve? Is the question here. We are covering these 6 major areas.
これ多くの企業さんが
One is simulation. Many companies are already engaged in this simulation, but we are working on the drug discoveries and energy decarbonizations and a few other areas. In the area of finance and insurance, we are conducting the financial products design and also risk estimation of a complex scenario. When it comes to optimization, since we are trading houses, we are in charge of energy and also logistics, so we try to make use of it. And the machine learning, the AI is consuming so much powers. So how do we offload some of the power used by the machine learnings? And this time, the cybersecurity, we try to create a new use cases using quantum resistant security. So this is a strategic partnership with the Quantinuum. As I just said, we try to produce use cases. Quantinuum provide technologies for us, and Mitsui and Co. commercialize it and market the product. Quantinuum has introduced the services in other sessions, so I don't have to go into the detail, but it's a world largest quantum computing companies, and they have enormous knowledge about the hardware and then software. These are their solutions. I think their characteristics is vertical integration type of this 4-track quantum computer and also SDKs, and also for EAS or IaaS type of use cases, they have Quantinuum Nexus platform, and also they have Ticket, and algorithm development for the machine learning is also done. This is the roadmap for the hardware. Left-hand side, 2 are already on the market, and H1 and H2 are already available on the market. 56 physical qubit for H2. So error rate is very low, and it is useful for simulation and other applications. By the end of this year, 96 physical qubits will be available. Error rate is going to be less than 10 to the power of -4. With this, you can work on this platform in the HPC. And 2029, several hundreds. And when you think of the error rates and in others, it's going to be maximum 1 times 10 to the power of -10. And this can be useful for various applications. And we are thinking of achieving this within 5 years. I mentioned a little bit about the quantum token. With the use of the quantum communication device, we just started working on it. Quantinuum owned the patent. Quantum communication and also fixed communications can be integrated. Quantum communication is only for 10 kilometers or so, and QKD can be used for just for the issuance of the coins or tokens, and combining this to the existing communication, you can also develop a great technology. So fraud resistant services and also anonymous communications, all available. I don't think you can do this with classic communication, classic computings, and this QKD is going to be used for this type of communication. The demonstration has been already completed in November 2024. It can be used for the financial institutions or infrastructure provider. We are engaged in several companies already. Left-hand side, this demonstration has been already completed. So now we are in the phase of a business verification. Mitsubishi Electric is working with the application for the platform. And we are promoting this business verification project with several partners. Mitsubishi Electric and 7 other partners are in this program. Continuum hardware roadmap also showed that the 100 logical qubits are already within the range of realization, and large-scale quantum computing platform should be enabled by distributed quantum computings. So photon-based quantum computings is going to be the answer for the scaling out. And 3 different steps or phases that we are thinking of. First one is the several tens of meters of the synchronous connection, and the second phase is hundreds kilometers of intra-regional connection, and finally tens of thousands of kilometers of a global connection. And if we can do this, we can communicate in the global basis. And we are planning to develop this technology so that the computer can be connected to any quantum computers in the world and can be created as a supercomputer. And we have been working on these applications, and the quantum computers are connected so that we can issue a quantum token, and these receivers can receive the token. So we are working on development of the application for them too. So we try to develop both businesses and also the application. And if you are interested in application development, or if you are interested in using quantum computing but don't know how to apply it, please come to Mitsubishi Electric or Quantanium. So please contact us. We have a booth with Quantanium, and also you can also contact me with LinkedIn. Thank you very much.